we are all set to go and get moving here. So we are going to get moving with lab number 12, called a microscale titration. Titrating chemicals is something that is very common in a chemistry lab. It's also actually very common in a biology lab as well. We are going to work on titrating chemicals, and the goal of this lab, there are actually 4. Goal number 1 is to better understand molarity. Now that's what we just looked at in the PowerPoint. The pheno paper, Cammie, hold on, let me grab mine. Let me go through the goals first. So the goals are to better understand molarity, which is what we just looked at. And then perform a simple titration, calculate the molarity of vinegar, and calculate the percent of acetic acid in the vinegar. The phenolphene paper is in a little container like this. There are actually only 3 of them in your lab kit. So you should see it. There's only 3 with the screw tops. Actually, there's only 2 with the screw tops. One of them is a flip top. Distilled water, I don't believe we need distilled water. So if you don't have your distilled water, you might be able to get away with regular water in this one because we're just using it to calculate drops. So let's go ahead and look at our procedure. Okay, the first thing we need to do is we need to calibrate our dropper bottle. Now, one of your dropper bottles says distilled water on it. If for some reason you used all of your distilled water, you can fill it up with other water. And I will show you how in a second. I will go get a container and I will be right back. If you used your distilled water in the last lab, and I just went and dumped mine out, so I now have an empty dropper bottle. What we are using this for is to calibrate our droppers, so we know how much is coming out. So if you used all of yours, take some either distilled water or regular water out of a container, squeeze your dropper bottle, and try to get some water to fill up. Flip it over, squeeze air out of it. Try to get some to get sucked up in your dropper bottle. You will only need a little. So I now have, I use my handy white paper here. I now have some water in my distilled water dropper bottle. So we are going to look at step 1. The dropping bottles must be calibrated. With the graduated cylinder and the dropper bottle containing water, count the number of drops it takes to get 1 milliliter. Now, a little refresher from the beginning of class. When you are reading a graduated cylinder, you want to be even with that graduated cylinder. So I put my graduated cylinder on my table. I get out of my chair, and I lean down so my eyes are reading directly at the 1 milliliter mark. You cannot read a graduated cylinder from up above. You are not getting an accurate reading. So what we need to do is calibrate our dropper bottle. We want to know how many drops are in 1 milliliter of water. So we flip our dropper bottle completely over so it is straight up and down. And you count. So I have my number. Then you are going to dump the distilled water. Get as much water out of the graduated cylinder as you can, and you are going to count again. You are looking at the 1 milliliter mark on your dropper bottle, Ethan, which is the bottom one. It says 1. And if you look at the top, you know it's a milliliter because it is labeled on top of your graduated cylinder as milliliters. You are going to record the two numbers you got on page 68. Everyone's number may be a little bit different. Depends how hard you squeeze the bottle. Then you are going to average the two numbers. Now you need to do number 2. So for example, my average, was 23. We're an average of 23 drops in 1 milliliter. Now I need to find, it says from result 1, the volume of 1 drop in a milliliter is, you will do 1 divided by whatever your number was. So mine is 1 divided by 23. So my answer for number 2 is 0.043. Yours will be slightly different. Now we are going to do number 2. Number 2 says put several milliliters of vinegar into a small beaker. Draw 1 milliliter of vinegar into the graduated pipette. Now remember, your graduated pipette has measurements on them. They're in the same container with the rest of your pipettes. I have one in my hand, and you're not going to be able to see it, but there are marks on it to tell me how many milliliters it is. 1 milliliter is about where my finger is. So I am putting vinegar into a beaker. Try to be careful not to spill it on yourselves. I poured way too much in. Make sure you also never pour it back into your mother's vinegar container. I'm going to draw up 1 milliliter of vinegar. And if I need to let a couple drops out to make it exactly a milliliter, and then you are going to put that in a second beaker. I'm going to put it in my small beaker. Now it says carefully measure 9 milliliters of distilled water. If I'm measuring distilled water, I would use my graduated cylinder. I'm going to go get fresh distilled water. I will be right back. Remember, as always, when you are measuring with your graduated cylinder, it goes on a hard surface, and you get even with that surface. So I'm getting off my chair. I'm going to measure 9 milliliters. Okay, took a couple shots, but I have exactly 9 milliliters. I'm going to take my 9 milliliters, pour it into my beaker with 1 milliliter of vinegar. I'm going to take my graduated pipette, and I'm going to mix. What we have made is a solution whose concentration is 1/10 of the vinegar that you had in your house. Next, we are going to get one of our well plates. This time, we are going to use our large well plate with only 24 wells. We are now on step 3 if you're following along in your book. Using the graduated pipette, put 1 milliliter of the diluted vinegar, so that's what's in your beaker, into wells D1 and D2. Now, it says see figure 12.3. It should look like yours with the solution in D1 and D2. Put this reaction Put the reaction plate on a piece of white paper. This is just so we can see color change more easily. So if you check mine out, let me angle mine here. I just have it sitting on, it's a piece of computer paper. It is nothing fancy. Now you are going to cut 2 pieces, I'm just going to rip them, of the Phenolphthalein test paper and drop it into the solutions. And what we are doing is we are trying to find out if these change colors. They're not going to change now. We are now doing our titration. When you do the titration, we need a dropper bottle with 0.1 molar sodium hydroxide. So find your sodium hydroxide, which is NaOH. Make sure you shake it. You're going to hold it completely vertical over well D1 and count the drops until the first pink color shows. If your paper is floating, please push it down. Then, once the first pink color shows, you are going to stir it with a toothpick. You can use a toothpick, you can use a pipette, it doesn't really matter. You're going to keep adding drops until the color stays for more than 30 seconds. What you are doing now is a titration. Then you are going to record that number, the number of drops, into step 3. You're going to do the same thing in well D2. and record it in step 3. Okay, if you guys either made a mistake or got lost and need to start over again, that is fine. Go ahead. But let's do it after class because the lab is relatively short. So that's actually the end of the lab. So if you messed up, that's science. It happens. It's unavoidable. Not a big deal at all. But we are going to, don't repeat it now. We'll repeat it at the end of class. So, basically right now we have all of our results. We have everything we need. We have 1, we titrated our drops. 2, we figured that out. 3, we averaged everything. Now we are going to use the results from 2 and 3 to calculate the average volume of the titrant that was used. You are going to use your number you got from number 2. Multiply it by your average from number 3. And that is how you will get number 4. Your homework tonight for this week is to do a lab report on this. You are only going to include questions 1 through 6 in your lab report. Okay, I do not want any other questions. Only need to include questions 1 through 6 in your lab report. This is a fairly simple lab. However, it is very easy to make a mistake. The lab directions are pretty straightforward. But if you put 1 too many drops in your well plates, it doesn't work. You get bad results. Titrations are used in science, especially chemistry and biology, all the time. I do not expect that when I get your lab reports, you are going to have very good results. I do not get very good results when I titrate. Even when I was taking organic chemistry in college, we would repeat titrations what seemed like for hours to try to get them even ballpark close to what they should have been. Part of chemistry is being very, very precise. I will tell you what my numbers were. I want to know your numbers, though, not my numbers. My average number of drops was 27. That was not very close to what it should be. The correct answer, or their answer, is actually 6 drops away from my answer. So I do not expect your results to be perfect. I do expect you to try. Okay, so if you made a mistake and you have to start over again, not a big deal. Go ahead, start over after class, some other time during the week, whatever, and you can go ahead and do that. But don't get frustrated if your results are not 100% perfect, because this is probably the lab that you are going to have the biggest variation from their results, or from a perfect result from any lab that we do. So we have 2 more classes. Next class, we are going to do, let me remember which lab. We are going to do the number 16, reaction rate lab. And you are going to do a lab on your own for homework. The last class we are going to present. Yes, of course, Savannah, you can certainly have a decimal point in your average. It's an average, so that's perfectly acceptable. What we are going to do right now is we have about 20 more minutes of class, so we are going to look at another problem with molarity. Now that we've done a little molarity lab, maybe it will make a little bit more sense to you. So let's take a look. This problem is actually kind of working backwards from where we have been. So this time, this problem gave you 125 milliliters, but you need to change this to liters, so it's 0.125 liters. And it told you that your solution was 0.720 molarity. And you need to know the grams. So we are going to write out our plan. So our plan is to go from liters to moles to grams. We're going to do this one together, and then I'm going to have you guys try one on your own. So make sure if you need some notes, you're writing down what you need to help you so that you can do one of these problems on your own in a few minutes. So jot down what you need from this problem. And now we are going to set our problem up. Okay, when we are setting our problem up, we have 1 mole of KCl is equal to 74.6 grams of KCl. That's another given that I will give you. We set up our 2 conversion factors. The first is 1 mole over 74.6 grams. The second is 74.6 grams over 1 mole. Okay, so let's set up our problem. 0.125 liters times 0.720 moles per 1 liter times 74.6 grams per 1 mole. So take a look at this. Make sure you jot down any notes you need, and then you are going to try one yourself. Okay, now we are going to try one on your own. How many grams of AlCl3 are needed to prepare 125 milliliters of a 0.150 molar solution? So, we are going to take a look. Oh, I want you guys to set the problem up. I almost gave it away. I'm going to go ahead and I will give you our given, which is 1 mole of AlCl3 is equal to 133.5 grams AlCl3. That is our given. So I want you to set the problem up. Your givens, your plans, your inequalities, and let's see what we can get. So let's go ahead and check out steps 1, 2, and the first part of 3. You should have your given, your plan, and your equations. And conversion factors. So check these. If you do not have one or the other, please write it down. You're going to set your problem up, and you are going to solve it. I'm going to send you a poll just to see how you guys all did on this one. Ish is good enough. The important part is that you can set it up correctly. I'm not so worried if you guys can multiply and punch numbers into your calculator correctly. But I want to be sure that you can set these up correctly. All right, and we are going to do one more. Here's our next problem. How many milliliters of 2 molar or molarity HNO3 contain 24 grams of HNO3? So step 1, you are writing your given. I will give you the conversion factor that you need. Go ahead and try to do step 1, 2, 3, and 4. Tell me when you have an answer. All right, it looks like most of you are stuck, so let's go ahead and work through this one. So we have our givens. Our givens are 24 grams of HNO3 and 2 molar HNO3. What we need is milliliters of HNO3. So we have our plan. We have grams, then we need to go to moles, then we need to go to liters or milliliters. Then we need to write our conversion factors. Next, we are going to set up the problem. So we have 24 grams of HNO3 times 1 mole over 63 grams times, now instead of just 1 liter, we have to use 1,000 milliliters because they want our answer in milliliters, per 2 moles of HNO3. So you carry out the multiplication and division. And you get 190 milliliters of a 2 molar HNO3 solution. Alrighty, so hopefully that makes a little bit more sense to you guys. Yes or no? I want you to rate on a scale of 1 to 5. 5 is the best, 1 is the worst. Do you understand this? Okay, 1 to 5, let's see. One to 5. 1 is I have no idea what you're doing at all. 5 is I understand this perfectly. Rate if you get these. Okay, if you don't understand these, I would like you to go ahead and look at the PowerPoint once it's up on the Moodle site. I promise it will make more sense to you. You may want to print it out so that you can actually like scratch on a piece of paper and do it. It will make more sense to you, Ethan, I think, if you print it out and actually look at it right in front of you. Rather, sometimes on a computer screen, it can be difficult to try to synthesize what's up here. So your homework tonight is to finish the lab. Remember, I only want questions 1 through 6. I want a lab write-up. What I'd also like you to put in this lab is anywhere you think you had errors. So I believe it was Ashley, maybe not, said that you had to start over again with your lab because you made a mistake. Tell me what your errors were. This is a very difficult lab. I would be shocked if everyone got through this lab with no problems at all. So at the end of your lab report, I want you to add an errors section. Next week, we are going to be doing another lab, and then the last class, you guys are going to do some presentations. Anyone have any questions? If you didn't understand anything at all today, then I can't help you much right now until you look over the Moodle stuff. And then if you still have questions, I certainly will help you through them. Anyone have any other questions, either on the homework or anything, the lab, anything that we did today in class? All right, then we're going to end a couple minutes early today. I hope you guys have a great week. Enjoy the week. If you have any time to get outside, enjoy it. Have a great day.